Hey class, this video is on factoring and solving 3.1b. If you haven't taken notes on 3.1a yet, you're going to want to stop and go back, and that one's in more detail about factoring. This one's going to be focusing more on the solving. First, we're going to review a few things, including the greatest common factor. So it's the highest number or variable that divides into each term. So our rule of thumb is to always look for the greatest common factor and factor that out first if it exists. Remember, that's the highest number or variable that divides into each term. So in the first example right here, 5 and 10 are both divisible by 5, so I can take out a 5. And x to the fifth and x to the third, I can take out just 3 x's. So x to the third is the highest that I can take out, which means I'm dividing each term by 5x to the third. So there would just be a 1x squared left in the first term, and 10x to the third divided by 5x cubed would be 2, and the x's would simplify to 1. So that's the first one. Over here, 4, 2, and 6 are all divisible by 2, and x cubed, x, and x squared, and x, I can take out an x. Taking out a 2x out of 4x cubed leaves me with a 2x squared. Then I'm going to have just a minus 1x left there. And negative 6x divided by 2x is going to be negative 3. And then we can check if this factors any further, since I have a quadratic trinomial there, by testing to see does a times c, which would be negative 6. Can I make factors in negative 6 that add up to negative 1? And I think I can with negative 3 times 2. Negative 3 times 2 is negative 6, and negative 3 plus 2 is negative 1. So I can factor this one a little bit more by, I know it's going to be 2x times 1x to get the 2x squared. And then I need to use these two in my inside my FOIL. So I can multiply the 2x times positive 2 to get 4x. Oh wait, I want it to equal 2. I want it to equal 2x. So I'm going to multiply it by positive 1. And then I can multiply the 1x by negative 3 to give me the negative 3x. And then negative 3x and 2x gives me the negative 1x. So the final answer would be 2x times 2x minus 3 times 1x plus 1. So that's factored all the way. But you definitely want to factor out the greatest common factor first and get it down to a quadratic trinomial before you factor any further. Okay, special patterns, difference of perfect squares. So perfect squares are those numbers, like when you square a number, like 1 squared is 1, 2 squared is 4, 3 squared is 3 times 3 is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, we could keep going, 49, 64, 7, 8 squared, 9 squared is 81, and then 100. So these numbers right here are what we call perfect squares. They are the numbers, the squares of the whole numbers. So when you have perfect squares and you have the difference, so that means subtraction of two perfect squares, it always factors like this. So if you have a squared minus b squared, so two perfect squares, it'll factor to a plus b and a minus b. So like this one, 121, I didn't go up that high, but 11 squared is 121. 12 squared is 144. So you're going to want to memorize at least up to probably 10 squared, 11, or 12 squared, so that you can recognize these easily. So 121 is 11 squared and x squared, and 16 is a perfect square too. So this one's going to factor to 11x plus 4 and 11x minus 4. Over here, x squared minus 25, this one will factor to x plus 5 and x minus 5, since 5 times 5 is 25. So you can always test that by multiplying it back out. Like x squared, you're going to get plus 5x minus 5x minus 25. And with perfect square, difference of perfect squares, these terms cancel and you're just left with the x squared minus 25. So that's why it ends up factoring like that. Both 4 and 9 are perfect squares, so this one will factor to 2x plus 3 and 2x minus 3. And x squared minus 9 is x plus 3 and x minus 3 in any order. It could be x minus 3 and x plus 3 as well. So difference of perfect squares is a really great pattern to recognize, and it'll save you some time. If you don't see it, you can still factor it using the AC, multiplies to AC, adds up to B method, and figure it out. There's also perfect square trinomials. Perfect square trinomials are ones that look like this. It's like a squared x squared plus 2ab plus b squared. So basically your first terms are squared, your last term is squared, and then in the middle you have twice a and b. So for the first one here, I have 4 is a perfect square, 9 is a perfect square, and 2 squared is 4, 3 squared is 9, and and then 2 times 3 is 6. So in the middle you have 2ab. If a is 2 and b is 3, then you have 12 in the middle, which is twice the product of a and b, 2ab. So basically I have these two on the end are perfect squares, and then the middle is twice that. If that's the case, it factors to, and it's really not worth trying to memorize this, but it factors to ax, it's either going to be ax plus b squared, or it'll be ax minus b squared, depending on if the first one is positive or negative. So in the first one, it's negative here, so both of these need to be negative. So it'll be 2z minus 3 times 2z minus 3. Or we could write that as 2z minus 3 squared. So perfect square trinomials. Here a would be 6, b would be 5. 6 times 5 is 30, so 2ab in the middle would be 60. So it is a perfect square trinomial, which means that it'll factor like this. It'll be 6w plus 5 times 6w plus 5. I know they're both plus because this one's plus. So it's 6w plus 5 squared. Again, you can factor these the regular way, the same way I taught you yesterday. But if you can recognize this pattern or the special pattern, then it saves you some time. Okay, so we're going to factor and solve now. The zero product property is what property we're using in algebra to solve these. The zero product property just says that any number times 0 equals 0. Okay, so first we're going to factor. Notice that yesterday we just had expressions, so there was no equations, there wasn't any equal sign, so today we have the equal sign. So we're going to factor on the left. First I'm going to take out my GCF, which 2 and 18 are both divisible by 2, and then x cubed and x, I can take out an x. That will leave me with an x squared minus 9. I can continue to factor, so it's a difference of perfect squares there, but if you don't see that, what multiplies to negative 9 but adds up to 0 because I don't have an x term, that's negative 3 and positive 3. So this will factor to x minus 3 and x plus 3. Then the zero product property says anything times 0 equals 0. So these are all being multiplied together. It's like a times sign here and a times sign here. So if 2x equals 0, then this whole thing would equal 0. So if 2x equals 0, well, x equals 0 is one of our answers, because if I plug in 0 there, I'd get 0 times whatever. I'd have 0 times negative 3 times 3, which is still 0. So 0 equals 0. So that one would be one answer. Or x minus 3 could equal 0. So what would make that one 0? Well, if x minus 3 equals 0, then x would equal 3. So if I plugged in 3 here, I'd get 0 times 6 times 6, and 0 times anything is 0, so x equals 3 is an answer. And then I have the last one I could have here. What if this one equaled 0? And then solving for x equals -3. So if I plugged in -3 to this x, it would also give me 0. And then it would be 0 times -6 times -6, which would be 0. So these are my 3 answers. I have a cubic, so I should have 3 answers. X equals 0, 3, and -3 there. So basically what you do is you factor it, and then you set each factor equal to 0 and solve for each individual piece. So let's try another one with greatest common factor. You're going to take out a 3 and then take out an x, which leaves me with just an x in my first term, and then a -5 for my second term. So I could have 3x equals 0 or x minus 5 equals 0. If 3x equals 0, then that means that x equals 0 is an answer. If x minus 5 was 0, that means that x equals 5 would make that 0. So those are my 2 answers there. X equals 0 and x equals 5. Okay, factoring. Here I have a equals 1. And so I just need to find factors of c, -15, that add up to -2. Since a equals 1, I know it's going to be x times x. So -15 multiplies to -15 adds up to 2. So at -5 and +3. So it would be x minus 5 and x plus 3. Since that's equal to 0, you set each factor equal to 0. And add this 5 to get x equals 5 is one answer. Over here, I'm going to have to subtract 3, and x equals -3 is my second answer. In the second example, example 5 part B, notice that it's not equal to 0. So before you can factor and solve, you have to, in order to use the zero product property, you have to have your equation equal to 0. So before I can start this one, I do need to move the 30 over by adding 30 to both sides. So I'm going to do x squared plus 11x plus 30 equals 0. Again, I have a equals 1. So what are factors of 30 that add up to 11? So we got 1 and 30, 2 and 15, 3 and 10, 5 and 6. 5 times 6 is 11. And since it's just x squared, it'll be x times x. And then it's plus 5, +5, and plus 6. Then you set each of those factors equal to 0. Because if x is -5, this factor would be 0, and then 0 times 1 would be 0, so that would make the equation true. I got -5 by subtracting 5 on both sides. And then for this side, if x is -6, then I would have -1 times 0, which is still 0, would make the equation true. I got -6 by subtracting 6 on both sides. So I get 2 answers there. X equals -5 and x equals 6. Note that my exponent was 2, so I have 2 answers. Okay, so to use the zero product property, you have to have the equation equal to 0. So I will have to add 4x to both sides. And then I will also have to move the 10 by subtracting. Notice I lined up the 4x with the 3x because those are like terms. And then I lined up the -5 and the -10 because those are like terms. So over here, I'm going to get 0 because both of those equal 0. And on the left side, I'll get 2x squared plus 7x. And the -5 and -10 is -15. So I know I'm going to have, since I have a 2x squared, I'm going to have a 2x and a 1x to get the 2x squared. And then you'll need to find out factors of a times c that add up to b. So a times c is -30. And they have to add up to 7. So -30, so they have to have a difference of 7. So 1 and 30, nope. 2 and 15, nope. 3 and 10, you can make 7 out of 3 and 10. So 3 and 10 give me 30. I want +7, so the 3 has to be negative. Those aren't what go in your in your box though, but you get those from here. So these two numbers being multiplied are going to give you the 10x and the 3x, negative 3x. So I can't make 3x with the 2x, but I can make 10x. And I can multiply the 2x times negative or positive 5 to get 10x. And then I can multiply the 1x by negative 3 to get 3x. So those are my two factors. Now if I want to solve, then I set each of those factors equal to 0 and solve for x. So this one is two-step equation. So first you have to add 3 and then you'll have to divide by 2. So this one I get 3/2 or 1.5. And then the second equation I have to subtract 5 from both sides and I'd get x equals negative 5. So two answers there. Okay, over here we're going to have to move the 4x over. There's no x's on this side, but I want it to be in standard form, which is ax squared plus bx plus c. So I'm going to put the negative 4x in the middle. So it'll be 3x squared minus 4x minus 15 equals 0. 3, 4, and 15 are not divisible by the same thing, so I cannot take out a greatest common factor. Since it's 3x squared, this time it's going to be 3x times 1x. And then multiples a times c will be 3 times negative 15. So 15 and 15 is 30. 15 more is 45. So negative 45 multiplies to negative 45 adds up to negative 4. So 45. 1 and 45 not divisible by 2. We had 3 and 15. I can't divide by 4. I can do 5 and 9. 5 and 9 I can use to make 4. So 5 times 9, and I have to have negative 9 since it's negative 4. So then I look over here, and I'm going to take 3x times what and 1x times what. Since 3 times nothing is 5, I need to use the 3 to make the negative 9. So I can do 3 times negative 3, and that will give me the negative 9x that I need. And then 1x times positive 5 to give me the 5x that you need. And 5x and negative 9x gives you the negative 4x in the middle. So we're done there. So 3x plus 5 equals 0, or x minus 3 equals 0. Subtract 5 from both sides. This is a two-step equation. Again, divide by 3, and x equals negative 5 over 3. This time we would not want to write that as a decimal because negative 5/3 is 1 2/3, which is 1.6 repeating. So we're going to want to leave it exact as an improper fraction. The second one I solve by adding 3 to both sides, and I get x equals 3. Okay, I'm going through kind of fast, trying to keep the video short. Feel free to stop and pause, rewind as you see fit. Example 7. 8x cubed plus 12x squared minus 8x equals 0. So first I'm looking for a GCF, which 8, 12, and 8 are all divisible by 4. Then I can take out an x as well, which will leave me, if I divide this by 4x, will leave me with a 2x squared. Divide this by 4x will leave you with a 3x. And divide this by 4x will be minus 2. And then I'm going to continue factoring. So since it's 2x squared, I know I'm going to have a 2x and a 1x. And then I need to know what multiplies to 2 and negative 2 for a and c give me negative 4 and adds up to 3. That's going to be 4 and 1, and I need the 1 to be negative. So 4 times negative 1 is negative 4, and 4 plus negative 1 is 3. Then 2x times what and 1x times what? So I can make 4x with the 2, and I can make negative 1x, because remember these are my x's, with the 1. So 2x times positive 2 is 4x, and 1x times negative 1 is negative 1x. And then remember, these two always have to add up to your middle term there to make sure that it works out. So then you have your factors, and then to finish solving, you take each factor, set it equal to 0, and solve. So this one I divide by 4, I get x equals 0. Add 1, 2x equals 1, divide by 2, x equals a half. And the last one, subtract 2, x equals negative 2. So there we are. I'm going to do one more, and that's the x squared minus 25 equals 0. Notice this one, if you solved with square roots, x squared equals 25. Square root both sides, x equals plus and minus. The square root of 25 is positive or negative 5. So this one can be solved with factoring or square roots. But if you want to factor it, since there's no b term, what multiplies to negative 25 but adds up to 0? That's 5 and negative 5. This is a difference of perfect squares, if you can recognize that pattern. This one factors to x plus 5 and x minus 5. So x plus 5 could equal 0, or x minus 5 could equal 0, so x could equal negative 5, or x equals 5. Sometimes written as plus and minus 5 for short. Okay, that's notes for today. Let's see, I have 2 extra examples. Maybe just this one here is a difference of perfect squares, so it'd be 2x plus 3 and 2x minus 3. So your answers would end up being negative 3/2 and positive 3/2 if you solved that one. This one you take out a 3 first, and then it will be easier to factor. Okay, I'm going to stop there because this video is already long. Thanks for watching. Hopefully it's helpful. I have some extra factoring examples out there, and I'm always there to help.